This is the second part of our model. We're going to take the model a bit further and we're going to introduce you to the parallel circuit. Hope you enjoy it. This model is exactly the same model as we've used before. So if you're not sure about anything that we covered last time, you can pause the video here and read about the different parts of the model and what they represent electrically. We've also had the rules about current, which we said were like lorries. We said that in a series circuit, all the lorries are counted are exactly the same at any position, which we said was equal to the current being at the same at any point. And we said that the Mars bars per lorry, if you take all the Mars bars per lorry that each lorry delivers to each shop, that would add up to the total given by the Mars bar factory. And we said that that's equivalent to the voltage supply being equal to the voltage across each of the components. This is the circuit that we're going to model with 2 cells, a switch and 3 lamps. I apologise, but in some of the situations the switch is on the other side of the cell. So this is how to build the other type of circuit. It's called a parallel circuit. In a parallel circuit you can work things individually. So how to start this, I've lit one of the bulbs, 2 cells, a switch and a lamp. I'm then going to get another lamp with 2 wires and I'm going to connect it over into the other lamp. So now if I switch the switch, then both bulbs light. But if I unscrew this one still lights because there is a path for the current to take that bypasses this lamp. So I'll put that back and then I can connect up my third lamp in exactly the same way, 2 additional wires. This is how you'd show a connected wire. I'll get the circuit diagram for you later. Now they should all light. Doesn't matter that they're not the same brightness. Again, I can undo any of these and the others stay on. So the one on the left is the circuit diagram, the one on the right is the actual circuit built. So this is the circuit we're modelling. You've seen the circuit diagram, you've seen the photo. This is the FET simulator. So we've got the switch open, which is like the bridge being open, no electrons because there's no route for the current. This part here, all the electrons have to pass through there. So if we break this bit, we don't have any current flowing at all. So if I close the switch, we've now got electrons passing through the cell and going to each of the 3 bulbs. So this would be equivalent of my Mars bar factory. This is equivalent of my Tesco. This is equivalent of my Aldi. And this is my equivalent of Sandu saws. And you can see that not the same number of electrons are travelling through each lamp, which is why this one's brighter, this one's less bright, and this one's dim. It's nothing to do with the fact that this is further away. This just has to do with the resistance. Okay, break the circuit and it stops the current. We had lots of problems with our old model, so we're going to look at a new model. This is a town called parallel circuit. You can see we've still got the 3 shops as we had before. All the roads are still one way. But this time there's more than one path for the current to take. That's why it's a parallel circuit. So I'm going to drive this lorry and we're going to see the 3 different routes that the lorry can take. We can set off here at the one-way street, and at this point we have a choice. We can either go to Tesco or we can go along the road. So let's take Tesco. So I can go through Tesco, I can deliver my Mars bars to Tesco. At this point I can't turn left, have to go right, over the bridge, fill up with Mars bars and back. Let's go again. This time I'm going to go along the road and I've got a choice here again. I'm going to go to Aldi, go through Aldi, can't turn left, have to turn right, can't turn down there, so I have to go over the bridge, through the Mars bar factory, and let's see if there's another route. So here I'm going to go to Sandu stores and back up again. So here you can see that there are 3 routes for you can take. all the lorries go over the bridge, all the lorries go past the Mars bar factory, and all the lorries come down here. But at this point, they then have a choice. They can take Route 1 to Tesco, they can carry along the road and go to Aldi for Route 2, or they can go along the road to Sandu stores. So let's have a look at what happens if we add some counters on the side of our road and start counting in different places along the road. So this time we're going to look at the parallel circuit. We're going to count the lorries again. I'm going to start down here. Okay, and this time I want you to be carefully thinking and trying to count. So we've got counter 1, 2, 3, 4, 5 in brackets at the top and 6 over here. All right, so let's set off. Now my first lorry is going to go to Aldi. And it's going to go back along here over the bridge, fills up with Mars bars, and it's going to go to Aldi again. Over the bridge, then they're going to go to Sandu stores. Then they're going to go over the bridge, and then they're going to go to Tesco. And then they're going to go to Aldi again. Okay, so let's have a count. So how many did this? Well, let's do these ones first. So counter 2. 1 for counter 2. 1, 2, 3 for Aldi there. 1 for Sandu stores. Over here. 1, 2, 3, 4, 5. 5 for counter 6. 1, 2, 3, 4, 5 for counter 1. And 1, 2, 3, 4 for counter 5. Well, that doesn't seem to be a rule, does it? Well, let's have a look. We've got 3 branches. A lorry could go to Tesco, a lorry could go to Aldi, or a lorry can go to Sandu stores. So what would that be? Well, that's 1 for Tesco, 3 for Aldi, and 1 for Sandu stores, which would be 5. And how many went past the Mars bar factory? 5. So it's looking like the current in the branches adds up to the total current. But that seems a bit strange, because what about this number 5, this counter number 5? Where does he come in? Or she? Well, if we have a look, counter 5 doesn't count the lorries to Tesco. It does count the lorries to Aldi. And it does count the lorries to Sandu stores. So this counter 5 should count what goes to Aldi, 3, what goes to Sandu stores, 1. 3 plus 1 equals 4. So this seems to be our rule. The current in a parallel circuit adds up to the total. And I can show you that in a photo. You can try it on the FET. So you can see by the calculation on the right that the 3 ammeters in each of the branches adds up to a total of 0.472 amps, and the reading on the meter measuring the total current 0.471 amps. So that's pretty good to me, and I believe that the current in the parallel branches adds up to the total current. Another photo here to show you. This time I've added in that extra meter. So that's like, if you remember, the counter 5, counting the lorries that go past Aldi stores and Sandu stores. So first let's have a look at the 3 meter readings down each of the branches. So that's like the Tesco reading, the Aldi reading, and the Sandu stores all added together. Well, that gives us 0.111 amp plus 0.126 amps plus 0.207 amps, which gives a total of 0.444 amps. And our ammeter reading, if you can see on the bottom right hand corner, reads 0.448 amps, and that's good enough for me. So let's have a look at those 2 to the left, the two to the left have 0.111 amp and 0.126 amps. When we add those up, it comes to 0.237 amps. And if you look at the back, at the top, the meter reading there reads 0.233 amps. And that's pretty close to what we'd expect. So it looks like this diagram does indeed prove that the current in the branches adds up to the total current. So now we've set our counters up, our ammeters. We've increased the cells to 2, just like it was in our circuit. We've still got the bridge, we've got the 3 shops, so no current because the bridge is broken. You can see that where that bridge is, all the current has to pass through there. So close the bridge. We have 6.07 amps through the cells, 6.07 here, because this is the total number. So that all the electrons go through here, all the electrons go through here. But at this point, we have 1.8 going up this way. We've got 4.0 going in this branch, and we've got 0.27 amps going in this branch. And you can see that if you add up 0.27 amps, 4.00 amps, 1.80 amps, you end up with 6.07 amps. That agrees with our adding up the currents in the branches, adds up to the total. This branch here, well, again, this is measuring the lorries going to Aldi, it's measuring the lorries going to Sandu stores. 4.00 plus 0.27 should give us 4.27. It does indeed. Break the switch, no current. So if you remember, we've got to now look at voltage. And remember that voltage was to do with the energy or the number of Mars bars per lorry. So Mars bars per lorry equals our voltage equivalent. And remember, it is the store manager, the Mars bar factory manager. She was the one that set the Mars bars. So I think this time we're going to go for 20. So she's going to decide that every lorry is going to get 20 Mars bars. So again, if we look here at the start, then this lorry has just been through the factory, so this has to have 20. When it arrives back at the factory, it must have 0. So remember, potential difference is the difference between the number of Mars bars at one side and the other of the component. So here it's going to gain 20 Mars bars. So we're going to take this lorry, remember, and we're going to take it along to Tesco. That's going to go along to Tesco. And think about where it's going to go after that. Well, when it goes from Tesco, it's going to go back over the bridge and it gets back to the Mars bar factory. So this seems a bit strange, but for each lorry going to Tesco, it has to have 20 here. It must have none here because it's no more deliveries. So it must deliver 20 boxes to Tesco. And there's the lorry going back over the bridge, 0 there, and then it gets filled up. Let's have a look at another lorry. This lorry down here, it's going to go to Aldi. Well, we know it's got 20 boxes here. It's got 20 boxes here because it's not made any deliveries. If it delivers to Aldi, well, it's only going to make a delivery to Aldi, can't go to Sandu stores, has to go this way and over the bridge. So therefore, again, it must have none here. So it's got 20 here. It's got 0 boxes here. So it must have delivered 20 to Aldi. How strange. What about the lorries that go to Sandu stores? Well, the lorry that goes to Sandu stores must have 20 here because it's not made a delivery. It must have no boxes here because it's on its way back over the bridge to get filled up. So again, it must have delivered 20 boxes. So I think that's not what you expect maybe, but what we found is that the voltage across each branch is equal to the supply voltage. In other words, if you're a lorry, you're going to deliver all of your energy, all of your boxes of Mars bars to the one store that you're going to. So in this parallel model, one electron only goes to one component in each route. So let's see if this works. So I must make sure I connect it to the right side. So here's my voltage across the cell. So that's like my Mars bar factory. That's giving me a voltage of 9 volts. So what would you expect across each lamp? Well, let's try it, and I'm hoping that you'll predict that this one is 9 volts. This lamp, 9 volts. This lamp should be 9 volts. So the voltage across each branch is equal to the total voltage across the cell. We can click it across there as well. That would be 9 volts. There to there, that would be 9 volts. So I hope you're really pleased that you now understand or can work out the current and voltage in series and parallel circuits. Because next lesson is time for a practice. So here we've got a real setup. So these numbers are what you actually get. It's very difficult to see. The one on the right is the measuring the voltage across the two cells. That's given us a total of 2.487 volts. And if we can look across each bulb, we have 2.443, 2.446 volts, 2.434 volts. Now I know for you, you think, well, that's not exactly the same. And my argument would be that there are some pretty poor connections, so they're wires. And if we're thinking about that in terms of our model to try and explain it, what we'd say is like some of the lorry drivers are really having trouble getting through the snow and getting through traffic jams on their route, so they're probably going to nibble a few Mars bars on the way. I also had to bypass a switch because if I put the connections across the switch, push the button, these numbers weren't very good because there's a really high resistance across that switch,